Good afternoon, ladies and gentlemen, and welcome to the sixth in the series of webinars by CPI Industry. My name is Hannah Jo Uy, and I am the Assistant Editor of Climate Control Middle East magazine. The focus of this webinar is on fire prevention and fire protection strategies. For COVID or not, the commitment to fire safety is strong and steady. We have a distinguished lineup of speakers, including from Oman, Canada, the United States, and the United Arab Emirates. They mirror the diversity of those of you who have signed in to attend this webinar from nearly 20 countries, which is truly amazing. I hope you match the rich diversity with plenty of questions for the participants. For the purpose of this webinar is to walk away with key takeaways in the forms of insights and recommendations. And with that, it is my duty to introduce you to Robert Davies, the chair of this webinar. Robert is the Director of Specialist Services, WSP Middle East, UAE. Robert has over 19 years of experience in the field of fire safety engineering, 13 of which have been in the Middle East. Since graduating from the Fire Safety degree course at the University of Central Lancashire, he has undertaken a variety of roles within the fire safety industry. In his current role, as well as undertaking design work and leading projects as a project director, Robert has been instrumental in growing and developing the specialist services team and creating a global network. Robert also undertakes the day-to-day management of the specialist services teams, financial reporting, and business development. Robert, the stage is all yours.
Thank you, Hannah. Very nice introduction, and you may have seen a floating cup coming in over the camera there. So I seem to, I need to lock my study down to make sure I don't have any more intruders. But welcome everyone. Thank you for joining us on this fire safety webinar. We've got, as Hannah says, excellent panel together today to talk us through the interesting topics that we're going to be discussing. I'm going to just touch on the Chapter 18 of the UAE Fire Code, which has a particular relevance to myself. It was there's a reform order that was introduced in the UK just in the years I was leaving the UK, and it was quite interesting that nearly 12, 13 years later, a similar arrangement, a similar set of rules and guidance came into effect in the UAE Fire Code. So let me just share my short presentation and I'll go through that. So the UAE Fire Code, the 2018 edition, has a chapter that covers the roles and responsibilities of various stakeholders. And really the intent of the chapter was to help those involved in the design, development, management, operation of buildings understand their responsibilities towards fire safety throughout the life cycle of building. And it's very, very comprehensive. It really does go into a significant level of detail, identifying everybody who potentially is involved and the type of roles that were expected. And that goes all the way from the designers, the houses of expertise who are there to review and assist in the approvals, down to the actual residents and occupiers of these buildings. And the intent of it is really to create an awareness of the mandatory duties of the various stakeholders and in their respective occupancy. So it goes not only in identifying a designer's or a developer's responsibility, but also relates to the occupancy types, whether it be healthcare or commercial, and identifies those responsibilities. I mean, effectively, it's there to ensure a collective effort to fire safety and prevention of fire through awareness, which is obviously a very important component in developing fire safety standards. We can have good guidelines, but they need to be adequately enforced and people made aware of the various requirements. And the guidance is very comprehensive, as I mentioned. So the content of Chapter 18, it covers the responsibilities of building owners, residents, developers, consultants, houses of expertise, and contractors. Those, for those who are on the call from the design side, they may seem like the obvious ones that immediately need to be covered. But in addition to that, it also covers the material manufacturers, the agents, not just the manufacturers, but also those agents and those suppliers, the testing laboratories and the certification bodies and their responsibilities in relation to fire safety. It also covers the responsibilities of assembly, educational, healthcare, office detention, more various occupancies, and the management and the occupants of those facilities. And one thing I think is important to note when you look at this is it starts to establish a legal premise. Now, it doesn't stipulate that, but going back to my initial comment around the UK's, well, to be specific, England and Wales regulatory reform order back in 2005, that came out as a statutory instrument to establish individuals or organizations' responsibilities to manage and reduce fire, the risk of fire. And effectively, this is doing the same thing. And that therefore creates an ability to prosecute against not performing those tasks. So it is something to just keep in the back of the mind. Somebody like myself who's been in the industry for 20 years now, it feels odd sometimes to be so explicit about responsibilities, but clearly they need to be identified so that everybody is following the same rules and as I say right at the beginning around awareness and making sure everybody's aware of the roles and responsibilities they have to minimize the impact of fire on the buildings that we utilize. So very quick overview of Chapter 18, and I don't want to steal the opportunity away from our lovely panel and the lots of topics that we're going to be discussing there. So I have a lot of speaker bios to cover off, and I will go through those. Anything that you wanted me to touch before I move into that, Hannah?
Hi, sorry, no, please go ahead. And
any questions? I guess I was asking, was there any questions that are coming in that may?
Okay. Well, we have a few questions that I could read them out to you now from the delegates, or if you want.
No, please. I think we're still on time, which is unusual for a conference. So.
Okay, sure. So we have a number of questions that came in during the registration process, and one that I'd like to read out now is from Ali Sadin from Innova, in Innova as an FM manager.
Mm-hmm.
What are the local legislative requirements to become a registered fire protection company in terms of operation and maintenance? I believe the existing market fire protection companies in terms of operation and maintenance are not competent, and that's why we failed to run the system properly and need an alternative.
Well, that's a very dangerous question, Ali, to ask me on such a broad call. In terms of competence, that there is obviously gaps. I think that's clear. We've seen numerous large-scale fires in the UAE, across the Middle East, actually. That is evident that there has been gaps in the knowledge. I know that the authorities are trying their best to tighten and avoid having those gaps, and that there is various rules and processes in place in the different local authorities here to ensure that those carrying out the design, carrying out the implementation and the operation maintenance are qualified to do so. And then one of those introductions was the House of Expertise that is now mandatory for the fire stopping and the facade elements as the construction goes forward. Yes, more can be done, and that is the development. And again, if I go back to my point around the UK had introduced a reform order in 2005, a similar approach was introduced in 2018 in the UAE. So it is a learning process and trying to get the best of the international experience into the local approach to the regulations. And I think we again are seeing that development again, or that maturing as we look at how Saudi Arabia is now developed its building codes based on the International Building Code series, and utilizing those.
Oh, yeah, thank you for that. We have another question from God Bless Rogers, mechanical engineer, geared consulting engineers. Is there any software that will simplify the design and sizing of fire sprinkler system and fire pumps? And what's the consideration to be taken? What measures should be taken for design and sizing of automatic fire suppression systems for data centers?
Okay, there is software that helps size the fire protection equipment for the various applications. So I'm aware of plugins to BIM Revit software, and also it escapes me now, but there was a piece of software that we were using a couple of years ago that, again, similar approach, helped us size the system automatically. So yes, I'm aware that there is software specific to data centers. I believe these softwares are applicable across various use types.
And I think we have time for one more question before introducing the panel. And this one is from Sunij Chako, Managing Director, Installation Dynamics. Insights on regulations of passive fire and fire stopping, applications for existing buildings, and maintenance of fire stopping. So I guess if you could share your insights on that. Should I repeat it?
Well, just my insights in general.
Yeah, it seems so.
Well, I mean, actually, that's how I started my career, was in fire stopping and the testing of fire stopping. And that was now 20 years ago. So I have seen the evolution in the testing, the quality of the products, the maturity of the suppliers and the applicators. I mean, there's always gaps, as Ali had raised on his question. But there is definitely a significant improvement in the passive fire stopping solutions that are available in the market, and we continually see the suppliers and installers stepping up their game, improving what they're doing, as well as the supervision teams understanding what is required. So it's got the right focus, I believe, now in the region. And it's improving. So still always more that can be done in that area, but the solutions are there. It's really about ensuring that the right solutions are installed and maintained.
And do you have any comments with regard to maintenance of fire stopping?
Well, a critical component. So the finished product as installed is great on day one. But as the use of the building or changes occur, decoration of the residence, for example, things will unfortunately change. We've recently had an experience where the work that was being done in a residential unit, they broke through the hollow block to try and install cabling, and in doing so, they didn't just invalidate the fire stopping that was there, they also invalidated the fire resistance that the blockwork would have provided. So it was quite an unusual scenario, and then we're looking for solutions to reinstate that. So it is a challenge. The maintenance aspect is very much key. Labelling schemes that have been introduced and are now more better regulated and we're seeing applied more often, help with understanding what has been installed and therefore what needs to be reinstated.
Okay, well, thank you so much for that. I think now would be the time to introduce
Wonderful.
the panel.
I will swap over to the speaker bio.
Okay.
So let me introduce our lovely panel for today. We have, first of all, Zakaria Alhini, who is a fire safety engineer who graduated from the University of Central Lancashire, which is a wonderful university. Anybody who went there is clearly doing well. You'll notice the bias on that. That was myself included. He completed a BS Honours in Fire Safety Engineering. He's currently working as a HSE engineer for for Worley Parsons Company and has been deployed for major power plant project for Oman Liquefied Natural Gas Company. We've also got Luke Cameron, who is a senior life safety engineer at AESG and has been involved in developing fire strategies for some of the company's most prestigious projects throughout the Middle East, UK, and mainland Europe. He leads AESG's Fire Life Safety Engineering Division, which specializes in the development of bespoke fire strategies that are designed to suit the architecture, with a goal to enhancing both the standard of fire safety as well as the overall building efficiency. We have Nora Antoon, who is president of SFPE UAE chapter and professional member of the SFPE, with over 16 years of experience in fire protection and life safety design and project management. She is currently employed by Jensen Hughes as a senior engineer and leads the hospitality operations in the region. Nora moved to the UAE in February 2015 and since then has been active member of the SFPE and has contributed and organised to many events, which I can absolutely vouch for, and thank you, Nora, for that. Ibrahim Hesham is a mechanical engineer for Allied Consultants and specialises in HVAC, district cooling plants and related infrastructure networks, from systems design, life cycle cost, till construction supervision and management. He specialises, specialities include piping stress and surge analysis, hydraulic modelling, CFD and smoke management. Shamim Rashid Sumar has also joined us from the US, so very good morning to you, Shamim. And she is Vice President, Fire Codes and Standards at the National Ready Mix Concrete Association in the US. In her current role, she works with the National Model Building Codes and International Standards Organization to advocate for non-combustible and fire-resistant construction. She also provides technical support regarding code standards, regulations, and legislation at the national, state, and local level. We also have Peter van Gorp. Peter is the Director of Fire Safety and Loss Prevention at MAB. He has been working as a fire engineer for more than 25 years, of which 15 he has spent in the Middle East. He handled building fire life safety projects ranging from schools, hotels, hospitals, to large shopping malls, to multi-occupancy, high-rise, and industrial developments, from initial concept to assistance during construction. He also has extensive experience in fire risk assessments of refinery and chemical facilities. And last but not least, we also have Mohammed, who is a consultant with Jensen Hughes in their Toronto office. So again, very, very good morning to you, Mohammed, and thank you for getting up so early. Previously, he worked with Jensen Hughes in Dubai. He has extensive experience in providing code consultant services. He has a master's degree in fire protection from the University of Maryland and is a professional engineer in North Carolina. So welcome to everybody on the panel. And so let me start off with the questions. And the first one, I'd like to ask Luke, in the context of the growing use of the Internet of Things and connected technologies, what innovation have you seen in fire safety systems in recent years?
That's a good question, Rob. I think there's been many, but I think the most important one is probably the incorporation and guidance on Class N circuits in the 2016 updated NFPA 72, which essentially just allows fire alarm circuits to be routed over Ethernet cables rather than your conventional systems. And the results of that are, it generally allows for systems to be continuously monitored easier, has the potential to reduce false alarms. It allows for a kind of predictive maintenance, whereby technicians know what the problem is before they're called to repair the system. So generally it just allows for a lot more operational flexibility I think. And I'm sure someone with a more electrical background can jump in on this, but I think that was sort of a key milestone in the development of the Internet of Things in accordance with NFPA 72.
Thank you, Luke. No, that's great. And yeah, very good point to kick things off. Can I ask Mohammed, do you have any thoughts on latest technologies that we're looking at?
Yeah, I would like to talk a little bit about actually emergency communication systems because it's one of the trending technologies that have been addressed in NFPA 72, specifically mass notification systems, because those are like intended to address not only fire emergencies, but to address other emergencies to help communicate the required actions and facilitate response at the level of between the emergency responders and like the public in like large facilities such as like airports, or it could be hospitals, convention centers, so that the audience know like what actions they need to take, like what level of information should be communicated to them so that they initiate like evacuation, relocation. And it requires actually like such systems, like aside from like the hardware or the software involved, actually there should be like a development of a risk analysis so that such system is coordinated with the emergency response or like the emergency planning in the facility. And I can tell like the latest editions of NFPA 101 and 5000 started introducing the requirement to develop such analysis to determine if such systems could be required depending on the occupancy and like the occupant load expected in the building itself. So this technology until now, like it has been like there is like public address systems like installed in buildings, but they have not been designed to address like multiple like emergencies or like issues like apart from fire emergency until now, actually in the GCC region.
No, wonderful. Thank you, Mohammed. And Peter, do you have any thoughts on this subject area? New technologies that we've...
Yeah, you know, in general, there's, I'm talking a little bit of putting things a bit in perspective. The technologies, what we're talking about now, they were already there like 25 years ago. They were talking already about wireless systems like intelligent smoke detection systems, etc., etc. The problem with all these new technologies and the code, unfortunately, is always tends to run behind the facts, and that's not only when it comes to fire alarm systems, but in general. Also, when you talk about fire protection systems, water mist technology, for instance, and what they've done now, and that's where the performance-based fire engineering comes in as well, and is a good contributor. Is now they started. It's not now. It's already an ongoing process for the last 10, 15 years. Instead of going to spell out or to set out prescriptive requirements, they're going to create actually a whole new framework. The codes are the various jurisdictions create a whole new framework to which these new technologies have to fit in. One thing is what Luke mentioned there about the Internet of Things, where the fire alarms can go over cables, but it has to comply with certain performance requirements. So that is now and that's actually a good step for allowing new technologies to start to take place, actually, because as I said again, most of these technologies exist already actually quite a long time, and they have been fine-tuned over the course of the years. But very often what I see is that codes and authorities having jurisdiction put a brake on the implementation of these sometimes wonderful technologies just because there's no code compliance, or there's a lack of the prescriptive codes allowing for these new technologies.
Thank you, Peter. And actually, a perfect segue into Shamim in your new role that you have, and liaising with those standards organizations. How do you see that challenge around getting the standards committees to adopt new innovation?
You know, I want to agree with one point that Peter made, and it was something to the effect of codes and standards have sort of a lag time sometimes to catch up with some of these emerging technologies. But on the flip side, in some cases, you know, not that they can see ahead, but they are working on new codes and standards to address these new technologies as well. In the course of the discussion that we just had on emerging technologies and connection of devices to the Internet of Things, one of the positives that's had and that can be seen right now as we go through this sort of pandemic area is the ability to take a look and monitor your devices remotely. So one of the emerging technologies that is currently very much highlighted and is being worked on in the codes is this idea of remote monitoring and remote inspection, particularly when it comes to the fire detection and fire alarm world. Some of that going back decades was available. So you could provide reports on fire alarm detection sensitivity as an example. And as we move to connecting all of our devices, that allows us to do more sort of smart monitoring and maintenance, if you will. And so there are a number of codes and standards under development for looking at those devices remotely. NFPA is developing NFPA 915, a standard for remote inspection, and ASTM recently joined with the International Code Council to look at developing a standard for that as well. So codes and standards, the development process is very lengthy. It can take 3, 4, 5 years to really develop a first standard and go through that consensus process. But they've been doing a better job more recently of looking at emerging technologies sort of as they happen or before they start to be widespread in the industry.
Yeah, and a very interesting point you make there about some of these technologies being around for a considerable amount of time. I was talking about video detection the other day, and remembering when it was first presented to me as a young graduate, that's about 20 years ago. But of course that was very or less reliable at the time, down to the software, but the technology was there, and certainly the idea was there. So yeah, it's good to see some of these finally being implemented. And Nora, just pulling us back to that question around innovation in biosafety systems, or what would you contribute to that?
Yeah, there are 2 points. There is actually a point highlighted by Luke and Shamim, which is monitoring, which is starting on working on system that does monitoring. When we arrive to that point, that means that we design the system and maintain it properly in order to be able to monitor the devices and avoid nuisance alarms. And that was one of the subjects I wanted to touch base about, because especially that the conventional smoke detectors does lots of nuisance alarm, and having this step will help a lot in reducing that. If you allow me to speak a little bit about the nuisance alarm.
Absolutely. Well, let me segue out of the innovation topic, and I will come back to you on the nuisance alarm element. Yeah. Just talking again about technologies. One of the recent challenges that we've had in the UAE is the large-scale fires that have happened, and also there was a couple of really key comments there from Luke and Shamim around preventative maintenance. can I ask Zakaria just to comment on the growing role of thermal cameras in fire prevention and how the thermographic systems can help in detecting hotspots? You know, something that has already existed in the petrochem industry, and now using some of this technology in the regular building that we have.
Yeah, thank you, Robert. That's actually a good question. In our project, for example, that we had here in Oman, there are another sections deployed for implementing this and following the specification of thermal camera in regard to fire safety. But here I can stress something about the fire engineer's role in beyond the ordinary structures. So we will speak about the importance of means of escapes, especially on prisons, which is an ordinarily structure, and compare it to the standards, which is or the document, approved document B section, the requirement of P1 means of escape, which doesn't comply with the which is not applicable or not implemented in a prison structures. So escape normally is really required people to move from a place of fire to a place outside the building where a total safety is maintained. But this is not the case in a non-ordinary structure, for example, the prisons. So the cell which are designed in prisons will be made in a way that the fire can be contained later on, and the measures should be also taken in consideration, like for example, evacuate the elements from the fire or the elements from another cells or adjacent cells to that cells, and evacuate occupants before conditions of access to cell become hazardous. We can compare this from two different aspects by comparing for example, the fire compartmentations for the walls and floors. That should consider 30 minutes fire resistance wall for a single story building as per approved document B, or 60 minutes if the top story of the building is 18 meter or less. In another situations, it might be goes to 90 minutes of fire resistance if the top story is 30 or 30 meter or less, or sometimes 120 meter if the top story exceeds 30 meter. So the importance of fire engineers in unordinary structure will be influenced by the new technologies being adopted to that buildings or need to be implemented in that building, also the shape of the building, the complexity of that structure, what kind of engineering innovations is to be carried out on that building. So all these aspects will be a kind of challenge for a fire engineer.
Okay, thank you, Zakaria. And Ibrahim, I appreciate this is not your strength area, but just in terms of your experience in terms of the flame detection and those types of technologies, how have you seen their introduction into the design?
Sure. I'll take a little bit back. If we go to why the smoke is recognized the major killer, it's because the most fire-related deaths are because of the smoke inhalation rather than the burns. Hazard from smoke in buildings include like the carbon monoxide, the reduction of oxygen levels, which causes suffocation, the high temperature which resulted from the extreme heat dissipation of the fire, and the reduced visibility to the people who are escaping from the fire. This will greatly obstacle people from evacuation and reduce the rescue efforts. If we go for the objective of doing a smoke control system, it will be starting from controlling the spread of the smoke throughout the building and ensure the makeup of the minimum fresh air required for the evacuated people is maintained, protecting the egress paths to ensure that the smoke level is not lower than the emergency exit sign, so that people can see the exit sign while evacuating. Maintaining areas of refuge and facilitating the firefighters' access. And finally, of course, protecting the property. How it works, we start from the regular smoke control system, which relying basically on passive protection and pressurization. It's starting with compartmentation to control the smoke of the spread of the smoke, and which is like the fire zoning and fire barriers, and using the mechanical fans to control the smoke by pressurizing the zones to create a pressure difference across the barriers and to prevent the smoke from migrating from area to another. Pressurizing the escape routes, especially the stairwells and lobbies, is essential also to keep these areas as smoke-free escape routes. This is for normal buildings. If you go for atriums, which is like the large volume spaces, you will find the ordinary smoke control system by compartmentation is a little bit not applicable due to the increase of the height, which decreased the sprinkler system effect, finding no floor-to-floor separation and the interconnection between the spaces. Of course, also with the big space, you'll find a large amount of material which will cause a big fire load. Of course, utilizing the large volume space as a smoke reservoir and modeling the smoke layer descent is one of the traditional ways. But if you go through this, you will find that different methods can be utilized to analyze the smoke control systems, like algebraic equations, on fire modeling, and CFD modeling is one of the recommendations nowadays for the design of the smoke control system. The idea of the CFD modeling is very basic. It's dividing the space into large number of small spaces and cells, and used computer to solve the numerical equation for the flows, pressure, and temperature. In the current case, the technology with the huge processors in the computer are reducing the time of these simulations. There are many CFD models nowadays which is reliable and can be used during the design to simulate the smoke control system and to ensure that the escape routes are free of smoke and safe. Lastly, one of the models which it's well known is the fire dynamic simulator, which is a CFD model developed by the National Institute of Standard and Technology, especially for the fire application. It's free for no cost, and it is recommended to be used by the engineers during the smoke control systems design to simulate the fire scenarios and to calculate also the escape time to ensure that the smoke is not interfacing with human during evacuation. The sensors which mostly needed to be used to measure some parameters like the smoke, which is the smoke detectors, the smoke layer height, the carbon monoxide concentration, and smoke layer temperature. Of course, the beam detectors to measure the visibility, and the integration of this, as we were talking, it will be discussed by Nora.
Yeah.
Thank you. No, that was great. And just to, before we do segue into the conversation around reducing false alarms, I would like to close out the questions I'd raised there around the growing use of thermal cameras. So, Luke, can I just get your insights into those? As I say, particularly in regards to the high-rise building fires that we've had, can you see an application for them in that space?
Yeah, it's an interesting technology, thermal cameras, and I think one of the biggest benefits of them is that they're able to detect fires that are outside. So they don't rely on smoke reaching the ceiling and activating a detector. They rely on their sight. So I think there is potential useful applications, particularly in regard to external facade fires, which are a big topic now and in the last few years. I also think the importance of data centers, especially like with the pandemic and just how everything is so remote now, that like early fire detection in data centers is going to become more important, where they could be very useful, like high ceiling areas that are like not occupied or intermittently occupied. So yeah, I think there's a lot of potential. Obviously, they're useful for monitoring equipment as well, because they can pick up like temperature anomalies. But so essentially, they can detect fires before they begin in equipment. So yeah, there's lots of potential. They obviously have their own limitations. The biggest one being that they can't see through walls. So that's sort of a big limitation. And also because just like the science behind they operate in that, like thermal energy will usually like reflect off shiny surfaces like glass and stuff like that. So they're less effective, and like they would not be able to detect temperature anomalies behind a window, for example, because of that. And just because of all these limitations, I think that like the design of a thermal detection system is sort of reliant on the building layout. So I just think they're generally very bespoke. The installation is very bespoke, and like I think they're a good enhancement. I think they're good enhancements to standard systems, but I don't think they're at the point where they could be a replacement just yet.
No, I would tend to agree with you, but then equally going back to my point of seeing videos, well, what was it, video fire detection, I think I saw about 20 years ago, and then the version of it now is fundamentally improved because of the improvement in technology and software. So I think I wonder whether we might be revisiting this conversation in another 5-10 years and seeing what's then available in the market. But definitely an area of innovation from what I've seen. I mean, it's great to talk about all this innovation, but also with innovation breeds the challenges around operating these systems, maintaining them. Nora, can you just have a little conversation around the methods of reducing false alarms that we may then see from introducing these technologies that we're particularly reliant on?
Yeah. I would like to touch base mainly about the smoke detectors, because usually they are the main problems of false alarms. How I see things, if I want to put them simply, I would put them under 3 points. The first point would be how to select the detector, and the second will be where to locate it, and the third will be how to maintain it. So I would say if we go to these 3 points and we do them properly, we will be avoiding too much false alarm. And starting by how to select the detectors, an FPA includes many requirements about how to select the detectors, if it should be a smoke detector, a heat detector, and wherever it is placed, either in the concealed ceiling or it is placed in an area where there are too much humidities, next to bathroom where there is shower, next to cooking areas. So there are lots of requirements that tells you either you have to locate it, for example, 1 meter away from all these areas, or it has to be listed for the environment where this smoke detector is located. So I think if we use the correct detector, the correct detector listed to the environment, this will help a lot in reducing the smoke and reducing the false alarms in the future. Going back quickly to the location, FPA, I think it's chapter 29, it has too much requirement, let's call them best practices, about the location of the detectors where we want to really locate a smoke detector, where we have cooking areas, we have dusty areas, garbage room, an area like washing area where you have too much humidity. So everything, all these are already in the code, and even the proximity of the HVAC grills and the airflow, how much the detector is near or far to the airflow. If we locate them properly, that will help a lot. And after the design comes the maintenance. So that's the third point. In my opinion, if the system is well maintained, if the detector is cleared and it's maintained properly, like cleaned properly, free and frequently, I think this will avoid the too much. There's lots of voice alarm. And going back to what Luke and Shamim mentioned, in the new systems now there is monitoring, and when you monitor remotely the system, we can know when the detector is, for example, if there's any problem in the sensor and the detector, we can know before and try to replace the detector before even the false alarm happens. So that's mainly my insight about the false alarm. If we design it properly and we maintain it properly, the detector, we would not face false alarm. And I'm sure that everybody of us, and maybe most of us, have faced this issue either in the place where they live or in the place where they work. It's very common in Dubai.
Thank you, Nora. And actually, a little anecdote on that, and related to the passive side, we WSP were appointed to help resolve false alarm issues in an existing tower. And when we initially investigated, we found moisture because of the humidity in the actual sounder base, so the detector itself, and had initially assumed, well, okay, that it was down to that. And as we further investigated, and actually we started with a very much a look at the fire strategy for the building, ensure that everything's in place, rather than just look at what seems to be the problem. So while we were doing that exercise, we discovered a significant lack of fire stopping between the corridors and the apartments, and it was that thermal relationship between the corridor and which was being cooled all the time, and the apartment which wasn't necessarily, creating that additional moisture. And actually it turns out the part of the solution to the false alarm, although there were multiple other problems with the design, was down to the actual fire stopping. So it just shows you also how important a holistic design is, but also holistic installation of that holistic design to ensure a proper fire safe solution.
Yeah, also, I think, Robert, for example, the UAE fire code, they requires the smoke detectors in the concealed spaces if it's above, I think, 800. However, an FPA permits to the omission of these detectors. These detectors comes with their problems usually. They comes because usually the designer tends to install any kind of detector in these spaces, and they have to realize that it has to be selected as per this type of environment, which is very unique.
No, and a very good point. And one thing that I'm particularly excited about as an engineer is seeing that introduction of the Saudi Building Code, or effectively IBC in Saudi Arabia, and therefore a full adoption of an NFPA design approach, which then leads us opportunities, exactly what you say, to remove an element of the false alarm that was unfortunately introduced as part of the mixing of those codes that have happened over the years. Talking about, we've touched on smoke control and obviously a big theme around fire alarm systems, and we're just talking about false alarm there as well. A key element of all of this coming together is the integration of the various systems and trying to ensure that everything talks together, and there is no integration challenges. Peter, you've had lots of experience in the region, and what can you feed into the importance of proper installation, testing, commissioning?
Yes, I can. And what I want to say on this in general, the more sophisticated systems are, the more, and that's my experience only, the more prone things are to not working over time. And I've said it in previous seminars and everything as well. What is very much underestimated and not looked at also by authorities and engineers in general is the whole maintainability of systems. Simple, you find systems simply being installed and that you know damn well that they will never be tested because of the way they are installed. And that also counts for the fire detection and alarm systems. As Noura is saying, indeed, if you put a smoke detector in a very, or a sophisticated smoke detector in a very harsh environment, you can only be sure, you can be sure that after a year, the system will not work anymore. I've seen very sophisticated air sampling systems being installed in a refinery, in a switchgear building, and yes, they don't work anymore after installed just a year ago and simply not working, and the systems are switched off then. So it's all very good and well to have all these sophisticated systems, but the reality is that it's still up to the engineers to think twice before they implement or they say, okay, that's the best system for the application. Very often you can go with a more simpler device, but having a greater, a better reliability. And yeah, and that's again a strong opinion or an opinion from my end. Yeah, you can all supervise and monitor all these devices, and nowadays with the Internet of Things, every little component can be monitored, and then you get like on the fire alarm panel or on the computer, you get like this fault indicators. But usually, if you go and look in these buildings, yeah, you see fire alarm control panels or fault or computer screens with all the faults on there, and they are staying there because there is no maintenance companies, or the maintenance companies are simply not fast enough to start replacing all these elements and to fix the errors. So in that sense, there is still a huge challenge for the whole industry. And as I said again, coming back to my first statement, so having all this very sophisticated elements is sometimes, or is not necessarily the best way to do things from a operability and maintenance point of view. And that's something that actually the most engineers and authorities should really consider in their designs.
Mm. No, thank you. And Ibrahim, what's your experience on the installation maintenance side and challenges around that?
I've seen what Peter was saying is happening in a lot of places. Installation, especially in atriums, with these detectors, where location will not be feasible, for example, because of the internal arrangement or the internal architecture of the building itself.
Idea of having a holistic design, or as we call it here in the States, employing a balanced approach to fire protection is very critical. If we look at those overarching sort of principles, employing that balanced approach is really what's going to result in our success. And when we say that balanced approach, we are talking about, as you mentioned, combining our active fire protection systems with the passive and integrating with passive fire protection systems. Really, that combination together is what's providing highest level of protection. And I think we can boil this approach to three critical pieces. Detection, which we've really spent a fair amount of time talking about today, but really detection is critical. Knowing that you have a fire first and foremost is very important. You're not able to continue with management of fire without that piece of being able to understand that there is fire and where it is occurring, at which location. And obviously, you can't initiate fire suppression without having that detection in place, and suppression being, of course, key to managing fire once it occurs and controlling it. But that third piece often gets overlooked, and that's the containment side, the compartmentation. Very, very important in terms of being able to ensure that you have structural stability over the duration of evacuation, and also in order for suppression to be effective, it's very important that the fire is contained to a certain area. And often that coordination of the detection and suppression with the passive compartmentation is overlooked. There's limitations on the size of your suppression zones. As an example, in NFPA 13, those zones need to be coordinated, obviously, with the fire alarm and detection zones and the suppression zones as well. And that really, I think, smoke control, what my colleague Ibrahim was talking about, really illustrates that point kind of the clearest, in that integration of zones. And to Peter's point of systems working correctly, having that coordination of where the devices are and which initiating devices actuate which control actions is very, very important. And having that fire protection expertise, either to do the design or oversee and certify those designs, and also certify implementation in the field, ensure that it's working, is very, very critical. Maintaining the integrity of your compartmentation is something that is extremely important as well. Things like through penetration fire stop systems, through your fire partitions and barriers is extremely important. Maintaining that integrity is then going to be the path of success for your active systems working. So really, missteps in that coordination between the active and the passive is really where you have negative impact. And if you look at these large fires that we've experienced, historically and in more recent times all over the world, it's those missteps in the coordination, or even neglect of one of those three key pieces, or more than one of those three key pieces, that has really resulted in tragic loss.
Yeah, thank you. And Zakaria, just building on that again, around holistic design approach and ensuring that we have the collaboration between architects, engineers, and the firefighting community. Can you touch on that subject, please?
Yeah, normally in every project, of course, there will be some kind of change, let's say about the scope of work, because of some situations arise, or because of drawing need to be amended, whatever it is, and if it is linked to the fire design systems, it will going to affect that. So that is important to incorporate the fire engineers from the planning phase of the projects, and then to the construction phase of that projects, and so on. So the fire engineers will have a good idea about what's going to happen on the coming days. For example, the implementation, whether there is a change on that project, or the concept still the same, or the scope of work is still the same. So we need some sort of involvement of fire engineers in the different stages of the project, especially on construction sites. You don't know, one day they will come and the contractor will have an issue with the drawing, and that drawing having some link to the fire design system, for example, or alarm system or the sprinkler systems. So here there is another change. The fire engineer need to be more aware about the phases and when to participate on the project, so he can ensure all aspects of the design fire systems has been fulfilled within that project. Thank you.
Thank you. Thank you. So now I'm going to ask a question for all around, Luke, do you think there is room for new technologies, and what could you perceive to be potential technology that we might see over the coming years?
I think there's always room for new technology. It's always coming, but as we touched upon earlier, I think the wiring of fire alarm systems over Ethernet, over standard systems, will be a big one. You know, it just allows for a lot more flexibility operationally and with regards to maintenance and things like that. I think there'll always be new technology. It moves quite quickly, but I think some of the issues are, which we talked about earlier, are like the speed at which the legislation can catch up with the technology. You know, like it can take years for an NFPA update to permit use of a certain technology, and by that time, like, we may be moving on to the next one, if you know what I mean. So, but aside from the Ethernet connections and stuff like that, I think an increased use of like microprocessor technology and algorithms in smoke detection, I think that's one. I think false alarms have always been like a massive problem. So anything we can do to reduce false alarms is a big one. I just think algorithmic detection just gives us a lot more power to deal with false alarms in that sense.
Thank you, Luke. Nora, same question to you.
I think the integration between fire alarm and other system should be taken more seriously, because let's talk about the integration. For example, what we're talking about between the passive and active. We see many smoke dampers, for example, that are connected directly to the BMS instead of fire alarm, where an FPA is very clear about it. It has to be connected directly to fire alarm, hardwired. It has to be monitored all the time. 2 monitor modules for each damper, 1 control module for every damper. Monitor and control all smoke control equipment, and this is only for smoke control. I think NFPA has too many requirements about the integration of fire alarm with all systems, suppression, but also elevators, passive systems, smoke control, fire pumps, generators, and we see in many projects that are not connected properly. If we connect all of these properly, we monitor everything properly, I think the interfacing with the fire alarm, it would be much more compliant, more proper, and we can have a solid system, all of it connected to fire alarm in terms of emergency power, passive systems, elevators, smoke control system, fire suppression system, fire pumps. If all of these emergency equipment and systems are connected properly to fire alarm, that would be great. And an FPA includes requirements for all of these.
Thank you. Mohammed, your thoughts on, is there therefore too many interfaces or too much technology in a sense? Have we got to a point where the systems are overcomplicated?
Yeah, I agree with that, actually, with too many like products in the market, like offering like technologies or solutions that may or may not work with other elements of like the fire protection systems like in the building. So I would anticipate issues emerging in while contractors are attempting to integrate systems with each other and make them work properly, unless there's like coordination or like thorough knowledge like the product capabilities and conditions and limitations actually like communicated from the manufacturers to the installers, and eventually if the standards need to address any issues around that, actually, yeah.
Thank you. And Shamim, in your position talking to these standards organizations, do you see a risk that sometimes they're in strong arm by the developers of the technology, that we're starting to see solutions that aren't necessary?
Ask me a really dangerous question, Rob. You know,
sorry.
No, it's a fair question. In some cases, yes. You know, there'll be a strong sort of push from a particular industry or a particular, you know, representative of a certain industry. I think if we look at sort of the modern codes and standards development approach, though, and the number of people that are involved in technical committees putting that together, usually that can be seen from a mile away, if you will, and those attempts aren't always successful. And because of not only the consensus process, but the multiple revisions that occur every so often, even if something like that does make it into the code, there's always a process or a procedure to suss that out in time. And usually there's a balance that's struck in the codes and standards committees. So, you know, whether it's a passive type construction standard, usually there'll be a look to get, you know, sort of all of the industries involved. When it comes to active systems, there'll be a balance in terms of not only different manufacturers, but also all of the stakeholders involved. And I should clarify, this is in the United States, in particular with NFPA. There will be representation from you know, the technical community, whether it's consultants, researchers, you know, laboratories. There will be insurance industry stakeholders. There will be the manufacturers, and then also the consumer, which I think is probably one of the most important stakeholders is represented. So usually I would say that there are controls in place for that, and it's much less likely to occur.
Thank you. Peter, much earlier in the conversation, you'd made reference to performance-based design. You know, in that is that an opportunity for fire engineers to really weed out what is not appropriate for a specific building, to really delve into the code and identify what's appropriate for a particular occupancy without just doing a cookie cutter approach for every building?
Yes, definitely the performance-based design should only get into, I wish that the performance-based design would get introduced more and more and more. There's no limitation on this. And if you see sometimes systems being installed in certain areas as per the prescriptive codes, which you can see clearly that they don't make any sense at all. But are just installed because the codes are saying so. Yeah, if there is a culture, and again, if the codes and the legislation, and they do that already to a certain extent, allows for all this performance for the performance-based design to get rid of almost some of the prescriptive requirements, and that would be great, and I can only support that. And it's not so much the codes and standards that is the issue. It's very often the authorities or the people who have to make the decision ultimately. They have to get convinced, and for that one you need to create a climate allowing this engineered approaches, and that takes time, of course. We have seen I've seen here in Dubai, for instance, 15 years ago, yeah, nobody would even entertain a performance-based design. Now it is more and more accepted. But if you then go to a jurisdiction like, for instance, in the UK, London, there's even more. So in that sense, I can only support performance-based design. It's good for the whole fire safety community in that sense.
Thank you, Peter. And Ibrahim, so just talking about that potential for over-design, what's your view on providing more fire safety systems? Does that mean a greater level of fire safety?
I actually agree with what Peter was saying for the performance design and performance-based design and legalizing the performance-based design in most of the countries. But not only this, I'll go through from this to the implementation, which what we're talking about. Problem is that some of the project, you have a well-designed project, and after the design, many changes comes, which will be different than what you simulated in terms of compartmentation, fire zoning, and this is one of the major issues that we see nowadays. And adding to what Zakaria was saying, involvement of the fire engineer in all the stages of the project, starting from design to construction and up to the testing and commissioning, will restrict the changes which will happen in other disciplines, which will affect indeed the design of the fire and smoke management system. I think also including the BIM modeling in all of the designs, and to control the zoning and compartmentation is one of the good ideas that should be implemented in all the projects.
Thank you, Ibrahim. And Zakaria, just we've got 2 minutes left before we move to the Q&A. So your thoughts on technology as a closing remark, where do you see opportunity?
Come again, please.
Where do you see opportunities in new technologies that you feel would benefit the fire safety industry?
Well, the field I can see is I can say is a massive field. There are some chances for new technologies to come and can be effective in the field of fire safety engineer, especially in the performance-based design, because let's say about 80% of the projects being established today where fire safety systems or fire safety requirements need to be installed in particular occupancy or in that particular project is highly relying on the performance-based design. So the question that we should ask is where we are now in the performance-based design and where we want to be on the future. So I can say we have to identify the cutting edge methods in the performance-based design, and from this we can sense what kind of new technologies that are necessary to be the performance-based design, so can be perfectly implemented in a particular project.
Thank you, Zakaria. And that takes us perfectly on time to open up some questions for our attendees. Hannah, did you want to read through the questions we received prior to the session, and then I can lead on to those we received during?
Yeah, sure. The first question that we have is from Rajendran Sivaraman. Is there any field tests for fire stoppers? This wasn't directed to anybody, so.
Yeah, okay. So Peter, can you answer that? This is asking about fire stopping training. No, I think you're on mute, Peter.
Yeah, there is a test for fire stoppers, but I don't know exactly the number and the code requirement, but definitely there are. And what I can say is there are fire engineers who only do fire stopping, and they are specialized in fire stops. So yes, but I'm sure there is, but I cannot just say which code. Maybe somebody else can say that.
No, you're right, Peter, and it's not off the top of my head, but I know a number of the system integrators and suppliers do provide training, and there is international standards against which training can be achieved, particularly at ASTM, that will allow individuals to be qualified and experienced. And most of the training, as I know from my team, it can be done online.
Okay, we will do our best to go through all the questions as well, actually. And then the next question we have is from Rohit Salunke. Hi, is there fire protection system for the high-rise building facade currently a mandatory requirement in addition to use of fireproof cladding material?
Okay, wonderful. Can I pass that to Nora, please?
Yeah. I don't think there is a requirement to have a fireproof cladding material or fire-rated cladding material. I think the requirement are more have non-combustible material as per an FPA. And I also am not aware of any requirement of having fire protection on the facade. I don't know if they meant sprinkler or something, but my understanding to the question if there is any fire protection requirement for the facade, but no, there is not. And the requirement for the facade is to be done non-combustible and to pass the fire test as per an FPA 285.
Okay, thank you.
Yeah, no, and I would just add to that. So I can see the text there. So you're entirely right, Nora, that was part of the question was in terms of, is there a requirement to have a fire protection system? And all I would respond to add on to what Nora said is the intent is to have the facade so we don't require a fire protection system. And the challenge that we've seen in the market is that we've had these combustible facades that shouldn't have been installed in the first place. So it's going and doubling up is not the intent on new building design. There may be requirement for those solutions on existing buildings. And I know that there is various solutions being looked at. I won't give my opinion on where we should go in that regard. But
to add something to these questions, I know that Thomas Bell and Red that they did. They have launched a fire suppression system to the existing building where the facade is non-combustible and no more compliant as per the new UAE fire code. So they have some solution, and they launched a fire suppression system that is directly that has sprinklers that are directly projected to the facade. I'm not very familiar about this system, but I know about it. So that only for the existing properties, I guess. But it is not in the code. The code requires non-combustible material.
thank you, Nora.
Okay, and to the next question from Mr. Vinay Deshpand. Conventional FD is outdated. Intelligent addressable systems are way too old. The industry needs innovation. Is there any AI-based fire detection and alarm system offering?
Well, anybody, I just want to touch on one thing, that there is a, not specifically around AI, but I would say that there is innovation going on in the market. There is one company who recently designed a low voltage or a low power consumption detector, considerably so. It went from something like 200 milliamps down to 20. And if you then multiply that up by the number of detectors you would have in a high rise, that is to me, that is a great example of innovation, environmentally conscious solution. But in terms of AI, anybody want to take that answer or that question?
Yeah, I can jump in. Have an idea. As far as them being outdated, like conventional fire detection systems, they may be considered to be outdated, but one of the pros of them being in use a long time is that their reliability and durability is known. You know, so innovative and like new technologies with regards to detection is great, but it does take time before that reliability can be confirmed. But there is innovations in detection, particularly algorithmic, which I mentioned earlier, which they can essentially compare signals received in the detector against like databases of data to filter out signals that aren't typical of a real fire. You know, so there is innovation in that regard, but again, as I said, the reliability and the maintainability, which Peter touched on, of these systems takes a bit longer to confirm that.
Yeah, and just to touch on that, I mean, multi-sensor devices have been around for quite a number of years. That was always considered AI in that it was making a decision. So I would say that there is artificial intelligence in these devices, and Luke's right. Improvements. In fact, if I were to pick on an industry that I've continually seen improvements over the past 20 years, it has been the detection industry, as well as fire stopping industry. But that's a side note. Hannah?
Okay. Taking the signal itself and then comparing it, for example, for the smoke detector, taking the signal itself and comparing it, is it using or not before activating the fire suppression system is one of the implementation of the control intelligence in the smoke detection systems.
Yeah, agreed.
And the next question we have is from Raj Murthy. What is the life of these components, or after a certain year needs to be replaced?
So Ibrahim, can you lead on that one, please?
Yeah, it depends on the operation and maintenance manual you have for each and every component. Some components needs quarterly check. Some components needs to be checked every year. It depends on each and every component in the system itself. But for example, the main equipments, of course, they are rated for lifetime, which is like minimum 15 years and up to 25 years.
And I would add that it becomes an issue not necessarily of how long the devices last, but how long the manufacturer is able to provide replacement parts. So at some point, as technology improves, the manufacturers move on to newer and better products, and they stop manufacturing some of the older devices. And so the life of your system really then becomes reliant on whether those replacement parts are available.
Okay.
Thank you, Shami.
Thank you so much. Moving on to the next question from Mr. Prabhakar Naik. Is there a local institution to certify the fire rating for a duct or pre-insulated ducts? I understand they charge a huge amount of fees above 200K dirhams for each test.
Don't know the answer to that one. Anybody feel they can field that one? You might have got us on that one.
Can I ask you to repeat that question one more time, Hannah?
Sure. 1 second. Is there a local institution to certify the fire rating for a duct or pre-insulated ducts? I understand they charge a huge amount of fees above 200,000 dirhams for each test. This is from Mr.
Sorry, yeah. So the question was about fire testing of ductwork in the local market. Well, there is test facilities in the UAE. I'm not aware of one doing duct testing, and so that might be a valid point that the systems are having to be tested internationally, which has potential add-on costs of shipping and witnessing.
It depends on the material itself. For example, if you require to have a smoke exhaust or a makeup air duct which will be used during fire or emergency, these ducts, the material is black steel, and black steel will be going up to 2 hours for 40 degrees Celsius. So it's you go for the material itself, the specification for the material itself.
Yeah. But I think to answer that question, I'm not aware of anybody, particularly in the UAE, who's providing duct testing, but I am aware that the test facilities that exist are growing or trying to develop, and there may be a point in time, may even be imminent, where that is a feature or a test that can be conducted locally.
And I think this highlights sort of the theme of having a fire protection expert involved throughout the design stages. There are some decisions that you can make, and I think Ibrahim alluded to that earlier, on the types of materials and also solutions that can be provided to save from the outset on those expensive tests.
Oh, you're right, Shamim, and in fact, building on that, it may well be a scenario where the fire engineer is able to identify that that test was not required or misinterpreted. Certainly leading on what Ibrahim has said about the type of ductwork for smoke exhaust, very often when it's only required to be temperature rated, not fire resisting, it's the term fire resisting comes out, and that leads to the misspecification of the ductwork. So yeah, it's a good point.
Thank you. We have a question as well from an anonymous attendee. In the case of detectors requirement in concealed space in excess of 800 mm, from your experience, would it be better, more feasible to provide an upright sprinkler system in the concealed space to act as a detection mean instead of installing the required smoke detectors, and by that avoid false alarms in these spaces?
Well, I'm going to lead that towards Nora, because it leads into her comments around fully implementing an NFPA solution, which may actually, Nora, you answered the question.
I agree on the solution. I actually like it. When you have sprinkler, the sprinkler by itself is a detector. But I would say the answer is depending on the country. If you are in the UAE, there is a section in UAE fire code. It says you have to provide detectors in concealed spaces above 800, regardless if there is sprinkler or not. So we have to provide it. However, if you are following NFPA, not UAE fire code, then there is none. Then the NFPA even doesn't mention anything about 800. A sprinkler and detector will not be required if the space above the ceiling is non-combustible. So we will not require any of those systems.
Okay, thank you. We have a question from Amir Khan. Is there any guidelines in UAE code for performance-based design submission?
Well, since Peter talked about performance-based design, please, I think that's a good one for Peter to answer.
Yeah, the short answer is yes. There is in the UAE fire code, but don't ask me which part of the code it is. But there is, it's probably at the introduction of the UAE fire code, the first couple of pages, you will see something written about performance-based design. So, and what you need to do in order to submit.
To add to Peter, I believe it's also mandatory in here and in a lot of countries to do a performance-based design if the building is an atrium building.
Yeah.
Regular buildings are not, but atriums, yes, it's mandatory in most of the buildings.
There is, as Peter said, minimal guidance on it in the UAE fire code. I think it's page, correct me if I'm wrong, page 6 or page 8. There's a disclaimer that states nothing in the code prevents like alternative equivalent methods or designs being used, provided they can demonstrate that equivalency and they're approved by civil defense. Now, getting them approved by civil defense is probably the more difficult aspect of it, but it's a common disclaimer that's contained in NFPA codes, UAE fire codes, British codes, because like it's fairly well known that codes are generally a one-size-fits-all approach, and as buildings become more complex, performance-based design becomes more important. So and that there wouldn't be too much guidance within the code on performance-based design, because I think it would then become code-compliant design. You know, it's up to the fire engineer to fully understand the occupancy profile, the fire load within the building in order to demonstrate that equivalency and therefore satisfying the code functionally.
You're right, Luke. It kind of defeats the object to provide the solution. And interesting, Peter had talked earlier about the trend towards performance-based. We certainly are seeing it more and more in the region. When I first moved to the region back in 2007, we were doing a performance-based design on malls at the time. Mall of the Emirates, which I'd worked on previously, had performance-based design, and then there was a trend away from it, significantly away from it, and actually we've started to see the reintroduction and opportunities around that. So there's hope for the fire engineers. Yeah.
Thank you. Oh, sorry, you had something to add?
Yeah. Wait.
Yeah, go ahead, Hannah. Let's
okay.
get on to the next question.
Peter, I think you're muted.
Yeah.
There's a question there for Nora.
Okay. Okay, so I'll go on
Yeah,
then.
please.
Okay.
Yeah, please continue.
Okay. We have a question from Roberto. Thanks for the interesting topic. There will always be new technology, but ensuring this is installed and maintained appropriately and technically are vital for fire protection. Where is the industry/government right now in regulating the maintenance companies and policing fire engineers or competent persons of fire protection?
A good question. Can I get Zakaria to give us a flavour of Oman and tell us where they are? Because the ROP have always been quite good in this regard.
Actually, to work here as a fire engineer, you need to have a degree in fire safety engineering, and you need to be approved by the civil defense, or let me say the authority having jurisdiction. So once you are capable of approving that, then you can work as a fire engineer. In case if you want to run a consultancy for fire engineer, like for example, you want to open an office, fire safety engineering consultancy, then you will have to submit a master degree. You need to complete a master degree or bachelor degree with minimum 5 years of experience in the field of fire safety engineering.
And Zakaria, on the operation and maintenance side, so those in that side of the industry, what's the process in Oman for regulating that?
Come again, please.
For the operation and maintenance side of the industry, for those who operate the buildings and maintain the systems, what's the process in Oman for regulating that?
Actually, we can follow here the British standard or the NFPA standard. It doesn't matter. But once you go to approve your drawing with the civil defense, or let me say the authority having jurisdictions, they will approve it with the NFPA codes. But
no, so is Zakaria talking specifically about when the building is operational? Is there regulations that you're aware of for ensuring those who operate the building are qualified to do so, in the same way as you've identified on the design side?
Yes, in that case, people from, let me say, people from authority having jurisdiction or from the local fire department, they will come and inspect the building. They will test the smoke detectors. They will test the functionality of, for example, sprinkler systems randomly on different points of that line of the fire, of the smoke detection or the sprinkler systems. And when it's operate in normally, then they will approve that design.
Okay. I mean, coming back to my presentation around Chapter 18 and the regulatory reform order in the UK, the reason for that change was about moving the responsibility from a local authority, as Zakaria has intimated there, the authority coming and checking a building is operating properly, to the individuals who are actually in that building on a day-to-day basis, and shifting that responsibility. And that was the key for that change. And I think we've seen the initiation of that in the UAE Fire Code with the introduction of Chapter 18 back in 2018. That certainly gives the premise for the identifying the responsibility isn't just with the authority, it is with everybody who is involved in the process, down to that. I'm not aware of particular enforcement around qualifications and experience in the UAE or in other parts of the region to ensure those who are operating and maintaining buildings are suitably qualified, but certainly the foundation is there to move in that direction with the introduction of that chapter 18.
Okay, thank you. We have actually two questions directed to Ms. Noura from Vinay Deshpande. Why would a cooking area have a smoke detector and not a heat detector? And the other question or point is after design, it comes proper installation. The build changes during construction without involving a designer is a major cause of false alarm.
Yeah, so for the first question, yeah, in the cooking area, when the cooking area is big and close, it's better. I agree that it's better to go for heat detectors. But I think the intention of an FPA 72 is mainly the apartments where we have the living area, it's open to the kitchen and or a studio. So this is when all the area is open, and the requirement of the smoke detector with sounder waves in the living area or in the bedroom. When you are locating the smoke detector, it should be, I think, maximum 0.9 meter or 1 meter away from the cooking area. I think that's the intention of the code when you are locating the smoke detector with sounder waves in an area open to cooking. And for the second question, I think it's regarding after the building is constructed, as per a compliant design, sometimes there are changes either in the as-built or even after the operation. I agree that if we need to do architectural changes or even other kind of changes, upgrade the existing systems, we really need to involve a designer when the change is large or when the change is affecting the system itself. Because this is when also many problems, sometimes we have problems when we are changing even small things, when you are changing a storage to an office or when you are upgrading the existing system. So all of these, if they are large or they are changing occupancy or change of systems, they need to be a fire engineer or consultant need to be involved.
Thank you so much for that. We have actually two questions from Mr. Muhammad Abu Ali. The first question is directed to Mr. Muhammad. What is the technical difference between limited or non-flammable / combustible and fire resistance rating? How can we verify it on site or by material?
Yeah, actually, like each classification is determined based on a specific test method. Like for example, fire resistance is mainly intended or like determined by a test standard that determines how the element, whether it's like a fire separation or a component, would resist propagation of the flame or like temperature rise or how it's structurally stable. So based on the outcomes of that test method and the certification information provided from the manufacturer, then you can determine that's like a fire resistance rated material. And with regards to like combustible or non-combustible material, yeah, I mean like to determine the material as non-combustible, it has to be like either generically known as being non-combustible or pass also a certain test method, such as I think ASTM E136 as an example, or other equivalent test methods. So if the material doesn't pass that test, then you determine that it cannot be classified as non-combustible. So it goes automatically to the criteria of either limited combustible or fully combustible, based on other test methods, such as like surface burning characteristics, such that the material like may not exceed a certain like flame spread rating, beyond which then you cannot call it like limited combustible. And then based on that, the use of this material is like bound by the limitations of the code requirements.
Thank you for that. And his second question is for Mr. Zakaria Al-Hinay. When we have to use the term fire resistance rating and fire protection rating? Thank you.
Well, the fire protection rating, we will use it to describe the duration of the fire test exposure to which a door assembly or window, for example, was exposed to fire in accordance to an FPA 252. The fire resistance rating is the time that material, let us say the door or the windows, is take to withstand the fire exposure.
Thank you for that. I think we have time for a few more questions, maybe 2 more questions. We have one from Ulysses Cuera. Performance-based designs on fire safety are often modified / altered during construction. Some modifications, especially on passive fire stopping, are provided with engineering justifications from the manufacturer. Is there a limit on this engineering justification or modifications?
The only comment I'd have on that before I pass it over is around, touching on comment earlier, ensuring the fire engineers are involved throughout the process. There's opportunities to do performance-based design throughout the design and construction process, but it needs to be adequately validated and understood what's been done and how that's been installed. But so in a sense, there is opportunity, but it all relates back to ensuring that it's been done properly. Let me, Luke, do you want to jump in on that one?
Yeah, no, I'd agree. I think just from our discussion today, like it's clear how interrelated all these different elements are of the overall fire strategy. So, like changing one thing, although it may seem like a small change, might have quite a dramatic effect on the overall standard of safety, if you will. So, as you said, there is opportunities for performance-based design throughout the process, but I think it's important that the same fire engineer who's involved at early concept stage and in development of that strategy remains involved throughout construction, just to oversee that, because they're going to be the person who is aware of what affects these changes to the strategy late in design or during the construction stage will have.
Thank you.
I think it's also important to ensure that the performance-based design is assessed by those who understand. And if we take markets where performance-based design is a given, like the Swedish market, that is the design process. It's been done effectively by committee. Other companies evaluate the designer's solution, and they collaborate together to ensure that it's robust and appropriate. And I think that's ultimately what we're all looking for is to get the right solutions in place.
That's exactly the point that I was going to touch on, Rob. There's in the question itself, there's a key word there about engineering justifications from the manufacturer. And in many cases, this is really a conflict of interest, because it's in the manufacturer's interests, to put that product into service. So having those independent bodies to do the evaluation and to do the engineering judgments or assessments is very much important. And there is limitation on the actual stakeholders involved doing those evaluations.
Thank you. Maybe we have time for one more question. We have one from Manivel Periasami. Smoke detector is not mandatory for car park buildings per UAE code. Is there any other cost-effective solution to implement an early warning system to alert team response from the car parking buildings, fire and smoke?
I think, well, this is again understanding the fire strategy and what solutions are there to cover that off. But let Nora jump in on that one.
I think I would say the parking, it's better to be so. When they are sprinkled, there is no requirement for detection. Even heat detector, if we're going to put heat detector, the heat detector function will be same as sprinkler. I am not aware of any effective solutions in the parking. But I think when the UAE says, I'm not sure about this one, but the UAE says does not permit or it is not required, because if it is not required, we still can install it. But if it does not permit, the question is why we need another system. I think I would say the most important in the parking is to have CO detection, because the problem is in the CO more maybe than the smoke. But because the CO will, when it is on a certain level, it will immediately activate the fans. But again, it's a fire strategy concept that we need to look to this parking, why we need the early detection. Is there anything in this parking other than the cars that really need early detection. But usually when there is sprinkler, there is no need for detection.
To add also to what Dora was saying, if the opening of the car park itself is more than 20%, you will not need a smoke control system or a smoke exhaust system, which will lead to you don't need anything except the heat detectors or the sprinkler system. But if the opening is less than this and it's required to have a smoke exhaust system and smoke control system inside the basement, mainly you will use the CO sensors. It will work based on the ppm reading or the sampling point which will be installed, and then it will work based on the measures or the ppm for the activation of the fans as a smoke exhaust or as a ventilation outlet.
Thank you for that. Unfortunately, that's all the time we have for the Q&A. We have really great questions from the attendees, and thank you so much for that. We're just not able to address them right now, but we will make sure that we address them with our panelists, and we will all keep in touch, especially through the magazine. Rob, I'll hand it over to you.
Thank you. It's been an interesting conversation, and Luke touched on it there. It's really highlighted how important all elements of fire safety are, how important it is that we integrate them properly, that there is good collaboration between the architects and the engineers and the local authorities all the way through. And obviously building on that gives us the opportunity then to come up with design solutions that are appropriate for the building type that we're looking at. It was also interesting to see our international communities come together here, and we're still facing common issues globally. I think it's good to remind us that even though the UAE particularly has had some recent high-profile challenges, there is a global challenge, that there is a global fire safety community all working together to improve things, and I think that's certainly credit to the amount of attendees that have joined here, the questions that have been raised, and it shows that there is a great commitment for us to continue to improve. And we've touched on the term innovation. I think I've used the word innovation daily ever since the lockdown that we've all experienced, and experiencing the technologies that are available to us to improve our way of working, and then asking the question of what's next, what else can we do, how do we continue this improvement drive. So I'm quite excited to see how the fire safety industry responds to that. Shameen touched on the remote monitoring, which is something we've already had to implement. We're currently doing inspections of a hotel in Bahrain, Satram in the UAE. And we are working remotely on the Holy Mosque in Mecca in a similar vein. It just shows that there is ability to transfer that knowledge globally, as we've demonstrated here, and improve our industry as a whole. So thank you for all joining in.
Thank you, Rob.
Thanks, Rob. Thanks, guys.
Thank you.
Thank you.
Thank you.
Thank you, everyone. Thank you.
Thank you all.
Well, thank you very much, Robert, for your wonderful moderating job. My name is Frederick, and I welcome all of you once more to this fire safety webinar. I hope it has been, pleasure sharing, and knowledge sharing experience for all of you. Welcome on board, and we have 19 countries so far registered, and about 253 registered delegates as well. Now it is my pleasure, obviously, to thank all of you for making it today, and I will try to share my screen as well. There we go. Right, so I would obviously like to thank our supporting association, SFPE, for their support of this event. Sorry, something is wrong with my screen. and our strategic HVACR recruitment partner, carriersbay.com. Now I would like to take you through our upcoming webinars. We have one coming up on refrigerants review. It will be our 4th edition happening on 16th of July at 4:00 p.m. It will be a global event, so please make sure you tune in as well for that at 4 p.m. UAE time. Then we have one on smart HVAC systems on the 19th of July at 3 p.m. again UAE time. And hopefully in September, we shall be able to resume our physical event series. By that, I mean in hotels, if obviously the rules allow us to do so, and it is safe to do so as well. And I would like, if that is the case, then to welcome you in person, this time at the Client Consultant Contractor Conference with a featured co-located event, IT and HVAC Systems, which will happen hopefully in the hotel in Dubai on the 15th of September this year. And we shall be announcing very shortly the new categories for our landmark event, which is the annual Climate Control Awards. It will be the 10th anniversary this year. So please check the website on regular basis, climatecontrolawards.com, sorry. And you know, you are free to send all your entries regarding your projects or your products. So on that note, I thank you again all very much for attending today's event. I think and I hope it has been a good learning experience for all of you. Thank you for your support and your participation. Thank you. Bye-bye.